Hi, I'm Aaron. Today, we're at SMP in Białystok, Poland, and we're going to be putting 4 ignition coils to the test. First, we're going to start by testing the OE coil, then the Echlin coil. Third, we're going to test a low-quality, low-cost coil, and finally, we're going to test a coil from a premium aftermarket competitor. Helping us out today is ignition coil engineer Marcin. I thank Marcin. Now let's get testing. The 4 coils we're testing all fit the same application, the Ford 4.6 liter and 5.4 liter V8. For our first test of the day, we're going to measure discharge duration. Now, this is really, in milliseconds, how long an ignition coil is going to fire the spark for. So, the first thing we're going to do is test the OE coil to establish a benchmark. Marcin? Okay, now what are we seeing here?
We see secondary current, which discharge duration lasts for 0.99 milliseconds.
Okay, so just less than 1 millisecond.
Yes.
Okay. All right, now this looks different to me. What are we seeing here?
It is 1.12 milliseconds.
All right, so what does that mean on the vehicle?
It means that we have more efficient combustion.
Okay.
Stable spark of the spark plug.
Okay. Let's go ahead and put on the low-cost coil and see if that looks different.
Okay.
Wow, that's a lot shorter.
Yes.
So what?
Measure the value.
That's even a lot shorter than OE, isn't it?
Yes, it is 0.69 milliseconds.
Wow.
It's over 20% less.
It's almost 30% less than OE almost, right? Yeah. So it's a lot shorter. So what does that mean when it's actually on the vehicle?
We can have incomplete combustion of the fuel-air mixture,
Okay.
which can cause the reduced horsepower and increased exhaust gas emissions.
Now let's go ahead and put on the last unit. That's the premium aftermarket competitor.
Okay.
Well, that's a little better than the low-cost coil, isn't it?
Yeah, it's better. Okay, it's 0.84 milliseconds.
0.84. So that's still about 15% less than OE, isn't it?
Yes, it is.
All right, now let's do a little more testing. The coils are on the testing machine. Now we're going to test for spark energy. This is really the amount of energy in millijoules each coil is capable of producing during normal driving conditions. Of course, the higher the better. All right, what do we have?
We have spark energy of each part.
Okay.
For example, for the OE part, we have a value of 29.9 millijoules.
Okay.
For the second part, which is Echlin, it is 31.1 millijoules.
Okay.
Third part low-cost competitor, it is 29.2.
Okay.
And the last aftermarket competitor, it is 29 millijoules.
So what does that mean?
If you have better spark energy, you have increased engine performance stability, reduced harmful emissions, and improves performance.
So basically it will work better on the vehicle.
Yeah.
Now, let's go ahead and turn up the heat on this oven and see how these perform under high heat conditions. Okay, now we've been running all 4 coils at the same time in this high heat oven to simulate real world underhood conditions. And it looks like one of them has failed.
Yeah, the part number 3 failed this test.
Which one was 3?
It was low-cost competitor.
Oh, okay, low cost. I've got an idea. Can we cut these all open, take a look inside, and see if we can figure out why it failed?
Sure, no problem.
Cool, let's do it. Well, Marcin got these all cut open for us, so let's take a look inside.
Yeah, here we have the OE part. We can see the magnetic core is solid. We have 5 sections on the secondary coil.
Okay.
This is Echlin part.
Okay.
We have similar magnetic core as OE part,
Yeah.
but there are 7 sections on the secondary bobbin.
So why are there more sections?
More sections give us better high voltage distribution in the secondary coil.
Okay, and that's why we saw a little bit better performance?
Yes.
Okay. Well, this one looks different.
Yeah, this is low cost competitor part.
Okay.
We can see different shape of the magnetic core.
Gotcha.
And we have 8 sections on the secondary coil. Probably they tried to compensate these losses in the magnetic core in the secondary winding.
Okay, you know, funny enough, this one looks totally different than everything else. It was also the one that failed the durability test. Okay.
The last one is aftermarket competitor part.
Okay.
We can see very similar shape of the magnetic core as the OE part. We have 5 sections on the secondary coil.
Well, I think it was pretty enlightening to go through all these tests, run them under high heat, and then cut them open to see what they look like. And I think for me, the big takeaway is that, yeah, ignition coils may look the same on the outside, but there's certainly big differences in how they're actually constructed. And that makes a really big difference with how they perform on the vehicle and how long they last on the vehicle. So thanks for watching.